Thank you so much, all of you, for attending, and thank you, Albert, for the invitation. I'm Ekta Aggarwal. I'm a research fellow at University of Southampton in UK, and today I'll be talking about how understanding flood-induced human mobility using Facebook data. So I guess Albert has already mentioned, but I am primarily interested in studying the flooding impacts and response of people using geospatial data sets. I guess I don't have to emphasize on why it's important to study flood or identifying the flood impacts or identifying flood risk area, but I would like to start off with few flooding impacts, which have few flooding events which have happened in last 2 years. For instance, the Libya floods, which happened in September 2023, or the Pakistan floods, which Marilla mentioned in her previous talk, which killed thousands of people in 2022. The recent flooding in Spain, or be it the Texas floods, which happened in July this year. Primarily, floods causes like infrastructure damage. We have livelihood losses. There are health risks which are imposed to the societies and people living in those areas which are impacted by flood. Then we have food insecurity problem, and the most important is the displacement. So people are displaced from their homes which they have built in last like 20 years or all throughout their lives they have stayed at. So recently the Internal Displacement Monitoring Center, IDMC, released the global report on internal displacement. And the numbers were very shocking. About 9.8 million people were displaced as a result of disasters in 94 countries and territory, specifically in the year 2024. Now, this is about 29% increase in the number of people which have been internally displaced by disaster in the previous year of 2023. Further, when we talk about internal displacement movements, there have the record, as per the report, were about 45.8 million. And about one-fourth of all the disaster displacement globally were reported from the US. The numbers also show that about 5.4 million displacements were in India, which was the highest figure since 2012. And 29 countries and territories reported that their highest disaster displacement figures were recorded in the previous year of 2024. The report also showed that when we broke down the number of displacement as per their hazards, about 54% of them were contributed by the cyclones, which was followed by floods, which was about like 19.1 million. So the numbers are very alarming, and what I'm trying to understand and research on is how effectively can we track human movements during floods and understand their response specifically using the Facebook data. What spatial and temporal trends characterize these flood-driven mobility, and to what extent can these mobility and geospatial data be used to identify evacuation hotspot and also enhance our flood risk prediction and recovery planning. Sorry. So in my talk today, I'll be talking about the Bihar floods, which happened in last year, 2024. Now, Bihar is an administrative state in India, which frequently faces flooding during the monsoon season between July to September every year. But the floods of 2024, the floods of 2024 had impacted the communities in the northern state of Bihar and eastern state of India since September 2024. About 4.5 million people were affected and 2.1 million children were affected in 29 districts. About 700 schools were reported major infrastructure damage, and more than 500 villages remain submerged since mid-September of 2024. So to understand this mobility dynamics, both temporally and spatially, we are using the metadata for good, which is the Facebook population and mobility data set. Now, this data has been used for studying migration during COVID, global travel patterns, as well as movement during crisis. The data is collected daily and for 3 time windows, which is the midnight to morning 8, 8 to afternoon 4 p.m., and then you have 4 p.m. to midnight again. And the data is collected at UTC time zone. So as I previously just now mentioned that the data comes as 2 components. One is the user distribution and the second is the movement. So here is a map showing the Facebook user distribution, the average user distribution between May to November 2024 for the state of Bihar. Here we see that the yellow areas are where the number of users are high. Those are also corresponding to the to large number of people living in those areas. And second is the Facebook user mobility. Now, this data gives us information about how many people are traveling from one location to the other during that time of the day and of the year as well. The second data set we used were different socioeconomic data sets. So one of them is the World Pop 2022 data, which gives us information about population, age, gender, and to also understand the type of settlements or the rural urban and to understand the role of rural urban, we are using the type of settlement from the GHSL SMART data. So to start off, to finally understand how people are responding to floods, we actually use the satellite-derived flood inundation maps. Now, this was done in collaboration with WEATH, actually, where we use the Sentinel-1 data to map out the flood-affected areas. So here are 4 snapshots of the monthly flood inundation area from July to October 2024. In the month of August and September, we can see that the majority, that a large area was flooded or water inundated, during which the major flooding had happened. So how accurately does Facebook data represent the population? So for this, we correlated the number of Facebook users with the population derived from the World Pop and also tried associating it with the rural-urban classification from the GHSL SMART data. So we saw that the highest correlation was for the urban center, where it was about 0.741, and which was followed by the semi-dense urban clusters and rural clusters, which had about like similar correlation for about like 0.6 and 0.64. And how can we use to capture the impact of the floods using FB data? So we plotted the number of Facebook users with the cumulative rainfall for the study period of May to November 2024. We see that the number of users drastically decreased from about like 7.5 million in the starting of May 2024 to about like 4.5 million around the end of September 2024, and after which it slowly started increasing. Now, this could potentially be maybe due to the loss of internet and electricity in the area, the evacuations and displacement activities which were happening, the limited battery or device access which people had when they were impacted by the floods, and also the behavioral shift during emergencies, which meant instead of using social media for just like scrolling or leisure purpose, they were now not using their social media activities and were basically trying to save their lives from that specific event. So we found that there is a statistically significant negative association between rainfall and Facebook usage, indicating that increased precipitation corresponded with fewer active users. Further to understand that how does flooding influence the population movement dynamics, we now wanted to study the spatial and temporal movement of these users during and after the floods. So here's a representation of the flood affected areas and how the users are and how people are moving in that particular area. But what we tried is classifying these movement into 4 categories. Now these 4 categories are on your left, which are the NN, FN, which is the movement between the non-flooded areas. Then you have FF, which is the movement between the flooded areas. Then you have FN, which is a movement between the flooded to non-flooded areas. And then you have NF, which is the non-flooded to flooded area movement. So spatially, we see that the majority of user movement is happening between the non-flooded areas across the whole time period from June to October. However, the movement between non-flooded areas started decreasing from July to September, which are basically the green plots you see on the top. However, the movement from flooded to non-flooded areas are the blue plots, which you could see in the third row. And we see that the number of user movement is increasing from August, which is when the floods were the flooding onset happened between the August and September, and started reducing in October. And then you also have the non-flooded to flooded movement, where again we saw that the number of user movement was higher in August and September compared to the previous or the post month. Now, to put number on these spatial movement plots, we have these four category movement patterns. On the left y-axis, we have the total number of users. And on the right y-axis, we have the mean distance traveled by the users in those respective movement categories. So the first observation was that, as I had previously mentioned, that across all the months, the number of users were maximum for the non-flooded movement categories. However, for the rest three movement categories, which were the FN, NF, and FF, the highest number of user movement was around the month of August, which is when the maximum flood inundation had occurred. Secondly, we see that the maximum mean distance traveled across all the four categories was about 8 kilometers, again around the month of August. So this kind of analysis helped us to understand that what is basically people's response, and also trying to understand that what could be the implementation policies of a particular country regarding their disaster management policies. Another thing which I would like to point out in the previous plot and the figures over there is we see a very similar pattern for the flooded to non-flooded and non-flooded to flooded categories. Now, this could potentially be that there are rescue services which are coming into the flood impacted areas and rescuing people who are being impacted from floods. So that's why we see very similar both spatial pattern as well as time series pattern for these two categories. Now, since this is an ongoing work, what we are trying to do right now is developing a model and also adding in the socio-demographic data, where we are putting in whether the area is affected by flood or not, what kind of settlement is over there, the gender proportion over there, then you have age categories, the population, to finally understand what are the predictors which are basically influencing these movements. And such kind of movement would also help us identifying these hotspot in case of disasters. So the key takeaway point for today's talk was that there is statistical evidence which indicates that rainfall significantly affects the Facebook user activity, with heavier precipitation linked to lower engagement. Then the analysis enables mapping of where and when populations are displaced due to floods, and quantifies the extent of population movement within affected areas. Additionally, the study seeks to pinpoint evacuation hotspots and compare patterns across different flood impacted regions. Lastly, I would like to thank the group, the UKRI Evo Flood Project, which I'm part of, Beth's lab, which I had the chance to collaborate with when she was at University of Arizona, and all the collaborators from World Pop at University of Southampton in UK. So yeah, thank you. And this is my LinkedIn and email ID if you have any further questions. Thank you. Should I stop sharing my screen?
So let's see. Maybe it's good to keep it up and see what the questions
Okay.
are, and then you might want to scroll back if that
Okay.
makes it easier.
No problem. Yeah.
So thank you for your presentation. It was awesome. And to let everybody else know, similar as the talk we just had, if you have questions, please post them in the chat. Um, and I see that Ken has a question for you, Ekta. Do you or is there a way to get more granular demographic information from the Facebook data to understand, for example, how informal workers are responding to floods?
Mm, More granular demographic information from the Facebook data. Um, if I get correctly, does it mean to get some sort of other attributes of the Facebook data, like what kind of user population is using that data? Is
And that's correct, says Ken.
No,
So,
sorry. I don't think so. We have that information because this is anonymous data which is collected. So because of user information privacy, we sadly we do not have information about what kind of user is using the data, is using the Facebook. Yeah.
thank you. And then from a question from Dinook. Is there an API where mobility data can be pulled from, or is this data proprietary?
Well, you can go to the metadata for good website and put in a request. It's not available for commercial purpose, but if you are able to share some research interest and specify why you would need that data, then they could accept your request and start collecting it. Because this is something which I'm doing with WorldPop, and they had the data previously for a few specific events. So that's how they did it. And Meta approached them to use it, basically. So, being a larger organization.
Yeah, no, that's awesome. I This is new to me, so I'm glad that you presented this, and I wasn't aware
Thank
that
you.
this data was available. So let's see. There is a question from Elizabeth as well. Really interesting work. Thanks for sharing. I was wondering whether you have applied this methodology elsewhere, or if you have plans to look at other regions.
Yes, so we have plans to look at other regions. We do have data set for a few more case studies from US and Mozambique because the idea is more like understanding how vulnerability is driving these mobility patterns or mobility in general. So identifying the mobility patterns between different income group countries. First off, we started with this specific case study because we have data for like a longer duration for this case study. Like you have pre-floods, then during floods and post-flood to actually understand that how mobility is being impacted by floods. So sadly, for the other two case studies, which we had a look at, you do not have data for such a longer duration. But yes, we do have plans. I guess it depends on how the data is available.
Thank you. Um, I have one last question. I was actually wondering, you show the slide where there's an increase in rainfall, you see a decrease in Facebook usage, and
Yes.
I'm wondering if you have made an some sort of an overlay with the night lights, what is it,
Mhm.
nighttime lights or
Nighttime
something map.
lights. Yes.
Yeah, to
Yes.
see if that's correlated to, for example, the electricity loss you
Hmm.
indicated. Is there, do you see a similar trend with that data set? So that affirms, I guess, that less people are using Facebook because there's less electricity, or do they not correlate, or have you not studied this?
Yeah, I have not studied, but this is something which me and Beth were discussing, and she also like suggested when we were talking about it that it would be interesting to correlate it with the nighttime lights data as well. But yeah, it's something very interesting you have pointed out, which is somewhat in the pipeline, but I haven't done it yet, sadly. But I will, and maybe I'll get back to you on this thing.
Okay, so thank you. I see one last question in the chat from Antara.
Yeah.
Is this primarily mobility data of people who are really using Facebook at the time, or
Mhm.
just folks with Facebook on their phone?
Okay, so I guess I would say it's kind of both, depending on what kind of device you are using. So, for instance, with iPhone users, it always shows a notification when you open an app. Do you want the app to track your location? So, if you are an iPhone user, then it might be kind of that it's only tracking when you are using the app. But that's why the majority of the data which are collected is more of Android users, which is 99%, because the location is being tracked even in the background when people are not using the app.
Awesome. Thank you very much, Ekta, for your presentation.